Welcome to this comprehensive tutorial on creating a blockchain-based voting platform. In this session, we will explore the fundamentals of blockchain technology and how it can be used to build a transparent, secure, and immutable voting system. Our goal is to ensure that every vote cast is secure, verifiable, and tamper-proof. Before we dive into coding, let's quickly understand what a blockchain is. A blockchain is a distributed ledger composed of blocks that are linked together cryptographically. Each block contains transaction data, a timestamp, and a cryptographic hash of the previous block, making it secure and immutable. In our voting application, each vote will be a transaction recorded on the blockchain. This guarantees transparency and prevents any unauthorized changes to the vote count. Now, let's start by setting up our Java environment. For this tutorial, you need to have the following tools installed: JDK 11 or above, Maven for dependency management, and your preferred IDE, such as IntelliJ IDEA or Eclipse. Once you have everything set up, let's create a new Maven project. After creating the project, navigate to the project directory in your terminal or command prompt. Open your IDE and import the project. Now, let's configure the pom.xml file to include the necessary dependencies. With our dependencies set up, let's create our main classes. We will develop a class called blockchain, which will contain methods to create and manage the blockchain. Inside the main source folder, create a new Java class named blockchain. In the blockchain class, we initialize our chain and create a genesis block. A genesis block is the first block in our blockchain. It has no previous block. Let's define the block class now, which will represent each block in our chain. In the block class, we define essential attributes such as hash, previous hash, data, timestamp, and nonce. The compute hash method will generate a hash based on the block's data, ensuring each block is unique. Next, let's implement the voting functionality. We will create a method in the blockchain class to add votes as new blocks. Each vote will be encapsulated in a string format. For example, vote for candidate A. How does that sound? Now we can add votes to our blockchain. Each time a user votes, we will call the addVote method, and a new block will be added with the vote data. To make it practical, let's add a method that displays all the votes in the blockchain. That wraps up the core of our blockchain. Now we are going to create a simple console interface for our voting system. Create a new class named Voting System to serve as the entry point for interacting with our blockchain voting platform. In the Voting System class, we're using a scanner to accept user input. Users can vote repeatedly until they type exit. After that, we display all recorded votes from the blockchain. Let's go ahead and run our program. Launch your IDE terminal and run the Voting System class. Start entering votes in the console. Notice how new blocks are created for every vote? If you want to see the flow, we can add some debug prints in the methods when adding blocks to visualize the process better. To enhance our system, we can implement basic security features like digital signatures to ensure that votes are genuinely submitted by the intended voter. For that, we will use Java's built-in security package along with a simple public/private key encryption. In this code, we generate a public and private key pair whenever a new voter instance is created. The private key will be used to sign votes, and the public key will allow anyone to verify that the vote is valid. Next, we'll implement the functionality to sign a vote using the private key. This means a vote is not merely added to our blockchain. It is securely encrypted to ensure authenticity. With the sign vote method, we create a digital signature for the vote. Next, let's modify our blockchain class to take a signature along with the vote. This addition will ensure that each vote encrypted with the voter's private key is verified with their public key. Now, we need to modify the voting process to accommodate the signing of votes. Let's change our voting system main method to create a voter instance, sign a vote, and then send both the vote and the signature to be recorded. You have now built a robust voting platform that ensures that every vote is recorded securely and tamper-proof on the blockchain. To recap, we have created a blockchain structure, allowed users to cast votes, and secured those votes with cryptographic signatures. For further enhancements, you could consider adding user interfaces, using a database instead of in-memory structures, and integrating blockchain frameworks like Ethereum for a more advanced audience. Thank you for watching this tutorial on building a blockchain-based voting platform in Java. If you found this video helpful, please hit the like button, subscribe for more content, and let us know in the comments if you have questions or suggestions for future videos.